A very good morning to everyone. So welcome to lecture number 8 on the topic of relative motion. Okay. So yesterday we have finished the constant acceleration parts. Okay. We have started relative motion 1 week before, and this relative motion is studied under 2 dimensions. One is first one is for 1 dimension. Okay. When the object is moving only in 1 dimension, either x-axis or only in y-axis. Next, afterwards, we'll see in 2 dimensions. Okay. So within 1 dimension, we have finished the constant acceleration part, both in horizontal direction and in vertical direction. Yesterday, we have seen different models of problems. So today, we'll start with the constant velocity, next model. And variable acceleration also, we can apply this relative motion concept, but in our syllabus, we don't have. So let's let us finish it in 1 dimension constant velocity. So when the velocity is constant, what is the acceleration?
0, sir.
0, sir.
So the only equation in this model of problems is what? S is equal to actually ut plus half at square, but a is 0. So only one equation.
Plus to ut, sir.
S equal to ut. So only one equation you have. So now, so this model is as far as solving problems, you have only one equation. So in that sense, it's the simplest of the simplest, correct or not? Okay, where you don't have any other equation, because if you take any other equation, b equal to u plus at also, a is 0. B square minus u square equal to 2a, there also a is 0. Sn equal to u plus a in 10 minus half, there also a is 0. So only you have this equation only, s equal to ut, that's all. Okay, so in that sense, this is very, very simple. So let's begin with this. And in this, there are different models: trains crossing, trains crossing, riverman, aeroplane wind, and rain umbrella. Of course, within this, this first one is 1 dimension. This first one is what? 1 dimension actually. And slowly we'll move to the 2 dimensions. Only this one is called as 1 dimension. Okay. Remaining are 2 dimension. So basically, we are moving into the 2 dimension only, and in the 2 dimension, these models we are covering. So by this trains crossing model, we are going to finish 1 dimension. Okay, and then we'll see 2 dimension. Specifically, with this we'll start, and then we'll go into projectiles also. Okay, there is a relative motion concept in projectiles also. Okay, so let's begin today with this trains crossing 1 dimension. Yeah, see here, constant velocity in 1 dimension. Okay, trains are cars crossing each other, riverman problems. Of course, here both there are 2 models. One is upstream and downstream, that is 1 dimension. Next one is riverman problems, crossing the river in the shortest time and shortest path, where it is 2 dimension. Okay, and aeroplane wind problems, rain umbrella problem, these all come under 2 dimension. So by this riverman problems in upstream and downstream, we are going to complete in 1 dimension. So let's begin today this one, constant velocity. Okay, so there's nothing to what you call, there's no theory as such. So now let's begin directly with the problem. Okay, so put the heading as a constant velocity. Okay, so let us take one problem. Find the time taken. Find the time taken by train. Find the time taken by train to cross the bridge. To cross the bridge of 1 kilometer long. To cross the bridge of 1 kilometer long. Given length of the train is equal to 200 meters and the speed of train is equal to 72 kilometers per hour. Okay. So now, how do you identify whether the given problem comes under constant velocity model or constant acceleration model? Is in this model, there is constant velocity, we will have only velocities. There will be no acceleration. Okay, So by that we can just understand that this problem comes under constant velocity model. Okay, and whatever the velocity is given in this problem. Okay, of course, there is only one train, so one velocity. Suppose if there are two more bodies with velocities given, those velocities should be treated as constants. They may not mention that it is a constant velocity, but we should understand that first of all, this problem comes under constant velocity model. How? Because there is no acceleration mentioned. Okay, if they don't mention about anything about acceleration, then we should understand that that problem is based on constant velocity. And once you identify that this problem is based on constant velocity, then whatever the velocities that are given in the problem are constant, even if they don't mention. Okay, so that is what you have to clearly know. Okay, so now let's begin. Suppose let us say, close the door. Close the door. Close the door. Close the door. Yeah, so let's suppose let us say this is the train. Okay, suppose let us say this is the train. Okay, and let us say this is the bridge. Are you understanding? Okay. Okay. Maybe just 1 minute. Yeah. So suppose let us say this is the train of length. How much? This length of the train is 200 meters. Okay. Now, and it is going with a speed of what? 72 kilometers per hour. What is the speed in meters per second? Tell me. What is the speed in meters per second?
20 meters per second, sir.
Yeah. So we know V is equal to 72 kilometers per hour. That is 1 kilometer per hour is equal to 5 by 18 meter per second. Please remember. Always remember 1 kilometer per hour is equal to 5 by 18 meter per second. Okay. So with this conversion, we can convert this into 18 fours, 4 5s are 20. So always you should convert into meters per second. That is the SI units. Okay. So now the length of the train is 200 meters. Length of the train means this one. Okay. So from here to here, from the starting of the engine to the back side. Okay. So from here to here, this is 200 meters. Now, what is the length of the bridge? Tell me. What is the length of the bridge?
1 kilometer,
1000
sir.
meters.
1000
Yeah,
meters.
1000 meters. Now, see here. Please understand here very carefully. Okay. Find the time taken by the train to cross the bridge of 1 kilometer long. Okay. Length of the train is this one, speed of the train. Now, when is the train said to have crossed the bridge means when the last portion, that means when the last bogie, okay, crosses the bridge. Okay. So that means when this, suppose let us say, yeah. Okay. Now see here. So now when the train crosses like this, that means when the last bogie, okay, crosses the bridge, okay, then the train is said to have crossed the bridge. Okay. So now they're asking us to find out what is the time taken. Okay, what is the time taken? Okay, is it clear? So this is called as initial position. This is called as initial position. Okay, that means the train is about to enter the bridge, and this is called as final position. The train has crossed the bridge. Okay, so now this length is how much? 200 meters. This length is how much? 1000 meters. Now we want to find out what is the time taken for the train to cross the bridge. So only equation which we have here is what? Tell me, what is the only equation which we have in this model?
S is equal to ut, sir.
S is equal to UT plus half AT square is A is 0. So now
Zero.
how much distance it has traveled?
So 1200 meters, sir.
Yeah, 1200. It is not 1000 meters. That part you have to be careful. With what speed it is traveling? 20 meters into time t. So therefore, time is equal to how much? 60
60
seconds.
seconds, sir.
Meters per second. Meter per second. No? So therefore, answer also you'll get in 60 seconds. Okay. So very simple model. Okay. Of course, here we have only one train. Okay. Now we'll see two trains. Okay. So I'm starting with simple one. This one. Okay. I hope you understood. So here the most important thing is when it is above, initially we should always take the front part of the engine is at here. And finally, the last portion of the train is at here. Okay. That part you have to be careful. Okay. In one train problem, it's easy. When it comes to two trains crossing each other, you have to be careful. How to take initial and how to take final. Okay. Understanding is important here. Solving is very easy. Only S equal to UT. No matter all models are understanding. Even this also what you call the two-dimensional direction also, we have only one equation, S equal to UT only. But you will apply in two dimensions. One in X direction, S equal to UT. Another in Y direction, S equal to UT. That's all. Okay. So now let's take another problem. Okay. This time we'll take two trains. Okay. So now find the time taken. Find the time taken by two trains to completely cross each other. Okay. And there are two trains. Okay. For example, let us take this one train. This is one train. Yeah, this is another train. Okay. So there are two trains. Okay, one traveling towards right side, another one traveling towards left side. Okay. Now see here. Now they have given that. Okay, actually they have not. They'll just mention that the two trains are having velocities and the lengths of the trains are given like that. Okay, they won't give these what you call trains and all. Okay, just they'll mention in the problem that train one length is 110 meters. Okay, train two length is equal to 90 meters. Okay, and the speed of the train one is equal to 36 kilometers per hour. Okay, and then the speed of the train 2 is given as 54 kilometers per hour. Okay, they'll mention it like this only. They won't give these trains. Okay, which one is which side and all. Okay, so in the problem they'll just give like this only data. Okay, so from the data we just understand that what you call the two trains, the time taken by two trains to completely cross each other. Of course, here first initially traveling opposite to each other. That also they'll give here. Traveling opposite to each other. Okay, traveling opposite to each other. This is also given. And the data of these two trains is given. Okay, so now let us assume these two trains as like this. Okay, so first let us say initial position. How to take initial position and final position is what you have to understand from this model. That's all. If you can understand that one, how to take initially and how to take finally, then you can solve any type of problem. Okay. So now let's see. So let us say this is the first train. Let us say this is second train. Okay. So now how should we take is initial position, which they won't mention. They will not mention how to take and all. They'll just say, they'll just give the data. That's all. Okay. So, but the way to take these two trains is always take as like this, where the two engines, okay, the two engines are just at this point. Okay, are you able to understand? This is called initial position. Okay, which they won't mention in the problem that that what you call the two engines are touching each other like this, but we should take it like this. Okay, is it clear? So now what is the length of the first train? Let us take this as the first train. Okay, so length of this train is how much? 110 meters.
Is it 8 seconds?
Yeah, this, let us see. Okay, this is 110 meters and this is what? 90 meters. This is what? 90 meters. Okay, and the length of the speed of this train is what? 36 kilometers per hour, and the speed of this train is what? 54 kilometers per hour. Correct or not? Okay, so now find the time taken by two trains to completely cross each other. Okay, now here previous problem it was only one train. Correct or not? So we can easily solve. Correct or not? Okay, but whenever now two objects are moving simultaneously, what we should do? Whenever two objects are
Sir,
simultaneously,
apply relative motion, sir. Relative velocity concept.
yeah, if you stand on ground frame and solve this problem, you may get it by normal method, but it's very difficult as you go further. Okay, but when you practice that relative motion concept from these simpler problems, even if the problem is difficult, you can still apply the relative motion concept. So practice relative motion concepts. Okay, for this it's not required, but I'm telling you. Okay, so let us solve it by relative motion concepts. So first thing is what? Tell me. First step is what? In any relative motion concept?
To write the values in the ground.
Yeah, write the values in the ground frame, taking right side as positive. Okay, so that means when you stand on the ground, ground frame means you are standing on the ground and observing. So velocity of first train, or let us say a train or first train. Okay, so velocity of first train is equal to how much? Tell me. What is the velocity of the first train in terms of meters per second?
10 meters per second.
Yeah, into 5 by 18. So 10 I cap. Correct? 10 I cap. Okay. That's all. Acceleration we don't have to write. Why? Because we have to assume that it is moving with constant velocity. Okay. Next. Now this one. Tell me what is the velocity of second train?
15 I
Given
cap.
values are with respect
Minus
to
15 I cap, sir.
yeah, minus
15 I cap.
15 I caps.
yeah, minus 15 I cap. So this is with respect to ground. These are the values with respect to ground. Okay. Now what is our next step? Tell me, what is our next step? Solve it from either A frame or from
B frame, sir.
B frame. Here first frame or second frame. Correct or not? So let us solve it from first frame. Okay. Let us solve it from first frame or A frame if you call it as A. Okay. So what does it mean? You are standing on train 1. Then train 1 is at what?
Yes, sir.
Yeah. Yeah. Now, initially this is the situation, no? Correct or not? Initially this is the situation. See here, I didn't change anything. Correct or not? Okay, now see here. So I am standing on first train. Okay, now this train is at rest. This is not moving. This is not moving. Okay, this is called as my initial position. This is called as my initial position. This is not moving. Okay, this is not moving. Now, what is the condition in the problem? Find the time taken for the trains to completely cross each other. Now they have to completely cross each other means, now let us draw the final position. Let us draw the final position. That means when is the condition means what is the position where when the two trains are completely crossed? Okay, they are completely crossed. When do we say that they have completely crossed? Okay, is that now this train is not moving according to our first frame. Now this train is not moving, so that means this train will be like here only. It will be here only. Are you able to understand? This train will be as it is here only. Okay, this is this green color. Now which train has to move? Tell me. This has to move, yeah, like this. And when it comes like this, can we say it has crossed?
Sir.
No. When the last part of the bogie, are you able to understand that? Then we can say that it has completely crossed. Are you able to understand that? Okay, so that means Abhiram, mute your call.
Sorry, sir.
So now, when do we say that the train has completely crossed? Is that when the train comes this side? Are you able to understand that? Okay, when the train completely comes this side. Now, in initial question, it was here. Now it is moving. Now it has, when the train comes here like this in the final question, okay, then we can say that the trains have completely crossed each other. Okay, so this is called final position. We are still here. Now this is at rest. Now when you stand on 1 and observe 2, what is the velocity of this train? 2. What is the velocity of second train with respect to 1? Tell me. What is the formula? U of 2 minus U of 1. When we don't write anything with respect to ground, with respect to ground. So now that ground values are important. What is the velocity of second train with respect to ground? When you stand on ground, what was the velocity? Minus
59 caps.
I-cap. Minus, when you stand on ground, what was the velocity of first train? 10.
10.
So that is equal to minus 25 I-cap. Which means it is traveling with a speed of how much? Now 25 meters per second towards left side. Okay. So now see here. So now we have only one equation now. S is equal to U times of T. But now we are solving by relative motion. No? So you have to apply relative terms. So what is this one? U of 2 with respect to 1 and displacement of 2 with respect to 1. When you stand on 1, how much the second train has displaced, provided the first train is at rest. How much it has moved? Tell me. How much it has moved? Initially it was here. Finally it was here. 90 plus 110. Are you able to understand? Initially, this is 90. This is how much? 110. Correct? Now, if you want to know how much it has covered, just see the first part, what you call the engine starting point. Right now, initially engine starting point is here. Finally, it is here. Okay. So from here to here, how much the engine has displaced or traveled? 110. Sorry, this is 110, no? Not 100. Okay, 110 plus what? 90. So 110 plus 90, how much? Tell me. 200. So 200 is equal to, how much is this? What is this one? Second. What is the velocity of train standing on first train? That is 25 into T. So therefore, T is equal to how much? Tell me. What is the answer? 200 by 24. How much is this? 8 seconds. Okay. Is it clear? Okay. So like this, we had to solve. Okay. This is by relative motion concepts. Okay. The problem is very easy. Just you have to know this much only. Okay. This is the only calculation part. But you may ask, sir, why you need to explain all these things. The understanding is very important to solve little higher difficulty problems. Okay? So you have to understand, first of all, the question will be given this much only. They'll give the question as like this. Find the time taken by the two trains to completely cross each other when they are moving opposite to each other. Given this is the length of the first train, length of second train, velocities of the trains. Okay? I've understood how to do. Okay, so first you have to understand what you called this problem belongs to constant velocity model. second point, the velocities given are constant. Next, third point, we have to solve it by relative motion, right, from ground frame. Next, either you stand on first frame or second frame. Okay, so that is what you have to do. So I hope you understood, and then apply this equation. Only one equation is there. So now, shall I give one problem? Will you do? Yeah, take this problem. Third one. Two trains A and B are approaching each other. Are approaching each other. If they take 15 seconds to cross each other, if they take 15 seconds to cross each other, and if the velocity of A is 3 times the velocity of B, 3 times the velocity of B, find their velocities. Find their velocities. Draw the diagram. Getting the answer is not difficult, okay, very easy. But understanding the problem is very important. So there are two trains which are approaching each other, and if they take 15 seconds to cross each other, okay, that means in the previous problem, this time I have given now. Now you are asked to calculate what is the, and if the velocity of A is 3 times the velocity of B, find their velocities. Okay, I'll give 1 or 2 minutes time. Please draw it and then do it. Answer is very easy only, but drawing that diagram is very important, understanding. So please do it. Take 2 minutes and do it.
Sir, sir,
Yeah, you got the answer?
sir,
Yeah.
sir, what should we take the train length, sir?
Yes, sir.
Yeah, without
Yes,
taking
sir.
lengths, you should ask. Okay, without taking lengths, you cannot do. Correct or not?
Yes, sir. Either we should take distance of separation or either we should take the train length, sir.
Yeah, you should. So now see here. The train lengths are given as 100 and 200. Now you can solve.
Sir, velocity of first train is 15 meter per second, sir. And the velocity of second train is 5 meter per second, sir.
Yeah. So velocity of A will be 15.
Yes, sir. Same answer I got.
This is 100 and this is 200. Okay. So now I think you can solve it. Correct? So since we don't know what is the velocity with which this is the given starting point. Okay. Now these two trains are approaching each other, means their velocities are like this. Let us say this is VA, this is VB. We don't know what is this one. Let us say they told that if this velocity of A is 3 times of velocity of B, means let us assume velocity of B is x, means then VA will be 3x. And then now you can solve. Okay. Where first we will write down from ground frame. Okay. From ground frame, the values of velocity of A with respect to ground is equal to 3x I cap. Velocity of B with respect to ground is equal to minus x I cap. Next is from which frame you want to solve?
A frame.
Yeah, let us solve it from B frame. Okay, so stand on B. Okay, then B will be at what? Rest. Correct? This is a B. Okay, so initial position will be like this. Where you are standing on B. Now B will be at rest. Okay. Now A only will move. Now with what velocity A will move? Velocity of A with respect to B is equal to what? Velocity of A minus velocity of B. So this is with respect to ground. With respect, what was the velocity on ground for A? 3x
3x I cap.
minus of, this is minus x I cap. So therefore 4x I cap. So that means now it is moving with 4x. Now finally, this is initial position. Correct? This is called as initial position. Okay. Now when is the train is set to cross B? Okay. Means this now train, what is called train B will be here only. Train B is here only. Okay. So train B won't move. So train B will be as it is here. Now train A is set to have crossed when it moves from here to here like this. Correct? So now let us see. This is the final position. Initially, now this train is at rest. This is not moving. This is called as train B. Train B. Now train A is moving. So when it moves like this is the engine parts. This is the engine. Finally, the engine is here. Correct or not? So the engine has moved from here to here this much, which is nothing but the length of the two trains. Okay, this is how much? 100, and this is 200. Okay. And it is moving right side, so therefore it is plus. So I write S is equal to UB, which is nothing but what? A with respect to B, A with respect to B. I took B frame. Why? Because when I stand on B, A will move right side. So I can write plus. Okay, so 100 plus 200 plus 300 is equal to, what was the velocity of A with respect to B? 4x into how much time it has taken? Time is same.
15 seconds, sir.
Yeah, 15 seconds. Time is same whether you solve it from ground frame or from what you called one of the frames. Okay, so this if you solve, you'll get x is how much? Tell me.
5, sir.
Yeah, 5. So we took x for what? Velocity of train B. Correct? Velocity of train B we took it as x. So therefore, now the answer is what? Velocity of train A will be 15 meters per second speed. Okay, and speed of B is equal to 5 meters per second. If they ask velocity means this will be in one direction. If it is right side, then this
The
will be left.
velocity of B is minus 5 meter per second, sir.
Yeah, or otherwise, if it is right side, if B is right side, then A will be left side. Okay. Okay. Now,
Yes, sir.
now, should I give one more problem?
Yes, sir.
Yeah. So, continuing the same problem, that means in the previous problem, in how much time will the trains pass each other? In how much time will the trains pass each other if they are moving in the same direction? Previous problem was what? They are moving in which direction?
Opposite direction.
Yeah. Now they are telling that in the previous problem means data is everything same. Whatever data, that means length of train A. What was the length of train A? Tell me. I think 100. What was the length of train A? 100 meters. Yeah. First train. Length of B is what? 200 meters. And now speeds are also known, correct? So speeds are also given. What is the speed of A? 15 meters per second. What is the speed of B? 5 meters per second. Okay, so this is given now because why we have solved the previous problem. Now they're asking time. What is the time now? So that they pass each other if they are moving in same direction. Drawing the diagram is important.
Sir, is it 30 seconds?
How much? Yeah, 30 seconds. But drawing the diagram is very important here. Are you understanding? Here, drawing the diagram is very important. Okay, in textbooks, they'll give direct formulas. If they are moving opposite to each other, you add the, because only we have one equation, no? S is equal to ut. Generally, they'll ask this one. Now, only thing is this one, you just add the, what you call the two trains length. So 200 plus 200, 300. Now, if they are moving opposite to each other, you add the speeds of both the trains. If they're moving, what you call it, in the same direction, then subtract. Then 15 minus 15, 10. Okay. So solution is very simple. One step. Are you understanding? Okay. But understanding is very important. What I'm trying to do is, I'm not trying to get this answer. I'm making you to understand what is the how to take the initial directions. Okay. So in textbooks and all, they'll give direct formulas. This is the direct formula. Time is equal to S by U. Understood? If they travel in opposite direction, you add V1 plus V2. And this is the sum of the two trains lengths. And if they travel in opposite direction, sorry, same direction, L1 plus L2 by V1 minus V2. That's all. Okay. Are you understanding? Okay. So anyway, so now
1 second.
see, in physics, there are many ways to study. Okay. One is just learning the formulas and getting the answer. That is one level. Another level is understanding the problem and understanding the basic concepts and then applying in higher level problems. Okay. Okay. So now the way to understand this problem is, suppose let us say, okay, some students will write as like this. Okay. Suppose let us say we have two trains, correct? So this is first train and second train is what? Yeah. Now they told that both are traveling in same direction, no? Correct? Yeah. So that means now both are traveling in same direction. Okay. So first one is 100 meters, second one is 200 meters. So let us make it like that one. Yeah, this is 100 meters, first one, train A. And this is what? 200 meters, train B. Okay, this is train A, train B. Now this is moving with the speed of 15 meters per second. This is moving with the speed of 5 meters per second. Okay. So now, so is this diagram correct? This diagram is not correct. You should not take like this. Okay, when they are traveling in same direction means generally students will take like this. Okay, if I ask the answer, that means they'll calculate like this and then they'll tell. But when I ask the diagram, they'll draw like this. So that means the answer they got, but the understanding is wrong. The answer you got because of the formula. Okay, if you substitute, every problem will have formula, but you can't by heart the formulas for every problem. Correct or not? If you can by heart, it's okay. But that is one level of learning. Another level of learning is understanding the problem and actually visualizing Okay, that is very important. Okay. So the correct way to take this problem is, okay,
Sir,
yeah,
sir, the both trains are attached to head and tail, no, sir?
for
Means one
same
end of the
direction.
train
You're
attached to
telling,
other train, sir. Same direction. Sir.
yeah, that is the correct understanding. So that means whenever they're traveling in same direction means you should not take like this. You should not take like this. Okay, the way to take the what you call trains as like this. Okay, suppose let us say this is what we took train B. Correct? Train B is here. Okay. Now train A you should take it as the train A. We should take it as like this. Where? Okay. Now see here. Train A here like this. So they won't give. Now you may ask, sir, they should mention in the problem. That is what I am telling you. In this last 1 hour, what I am trying to tell you is in those problems they won't mention. And that is what I am telling you. Okay, answer you will get anyway. Okay. So the understanding is this one. Okay. They will not give you in the problem that second train tail is at the starting point of the first train or something like that. But you have to understand like this. Okay. So this is called as train A. This is called as train B. Okay. Now, whenever they are traveling in same direction, see here in the previous problem, how much time will the trains pass each other if they are moving in the same direction? Okay. And our general conception is this one. Generally, most of the students will draw the diagram as like this. But this is not correct. The correct way of drawing the diagram is like this. Okay. And when they're traveling opposite means what we should do, tell me. If in the problem they give, they're traveling in the opposite direction, then what should we do? Tell me. We should take like this. Is it clear? Are you able to understand? That is what we have done na? In the previous problem. See, any problem you see when they're traveling opposite to each other, we have taken like this. Correct or not? Okay. When they're traveling in the same direction means like this we should take. Okay, like this. So please remember this one. Okay. So this is the given. This is what given situation. This is the given situation. And from here now it's very easy. Okay. Now how do you solve? Just by solving from what we call relative motion concept. First step is what? Writing the values from ground frame. So what is the velocity of A with respect to ground? Tell me. I think 15 meters per second. So 15 I cap. What is the velocity of B with respect to ground? That is equal to 5 I cap. Because both are traveling in the same direction. See here, positive. Okay. Now solve it from which frame? B frame. Okay. If you solve it from A frame, you will not get it. Can you tell me here? Afterwards we can solve. Okay. So now solving from B frame is go and stand on the B. Correct or not? So now that means what? Now B. Now this is A. And this is B. Now you are standing on B. That means now B is at rest. This is the initial position. Now only A will move. With what velocity A will move? Velocity of A with respect to B, we know. Velocity of A with respect to B is equal to what? Velocity of A minus velocity of B. That means with respect to ground, with respect to ground. Velocity of A is what? 15 I cap minus 5 I cap. So that means how much? 10 I cap. So that means now it is moving with 10 meters per second. Now finally, what is the state? Finally, now this train will not move. That means which train? The train B. Train B will not move. So that means train B will be at here only. It's not moving, see here. Only train A will move like this. Okay. So now train A, when it is said to be crossed, tell me. When do you say
last
it is?
Compartment crosses the train.
Yeah, when this one. When it has crossed like this, then we can say that this is the final position. Now you are still standing on rest only. still standing on B. B is at rest. A is moving. Now A's engine at initial position it was here, and the final position it was here. So how much it has traveled is nothing but the total length of the train. Okay, which is what in most general textbooks they'll give like this. Okay. So now we have the equation S is equal to ut. Now what? A with respect to B, A with respect to B. Okay. So how much it has traveled? 300 is equal to 10 into T. So T is equal to 30 seconds. Is it clear? Easy or difficult?
Easy, sir.
Easier. Yeah. So like this, we can discuss. Okay. Yeah. What is the time? 7:58. So I'll give one problem as homework. Please do it. Okay. I think fifth one, correct? A car. Please note down. Okay. A car traveling. Whatever concept we applied for trains, same thing for car also. A car traveling at 60 kilometers per hour overtakes another car traveling at 42 kilometers per hour. Traveling at 42 kilometers per hour. By the way, the previous problem, can you solve it from A frame?
Yes, sir.
Yes, sir.
Have you solved it?
Sir, I solved
Yes,
from
sir. Yes, sir.
How much you got?
Same, sir. 30 seconds only, sir.
30 seconds only.
Yes,
Yes.
sir.
Okay. A car traveling at 60 kilometers per hour overtakes another car traveling at 42 kilometers per hour in the same direction. In the same direction. In the same direction. Okay. Each car has a length of 5 meters. Each car has a length of 5 meters. Okay. Find, standard question, time taken for overtaking. Very easy. Second one, total road distance. This is very important. For overtaking by the first car. Are you understanding it? Okay. The total road distance for overtaking the first car. Okay. So first one answer I am giving, very easy, correct or not? Whenever they are
Sir,
traveling the
is the
same
time equal
direction.
to 2 seconds?
0.5 seconds.
Yeah.
Sir, 2 seconds, sir.
Okay. Because the total length is what the time is equal to total 5 plus 5. Now whenever they are traveling the same direction means you just have to subtract. Okay. 60 minus 42. How much? 18.
18, sir. 0.5 seconds.
Yeah,
sir.
18, that is 18 kilometers per hour. If you convert into meters per second means 5 by 18, that means 5. So 10 by 5 is what? 2 seconds. Directly we will get as far as the answer wise. But diagram wise you draw, then you can answer the second question. So answer for the second question is 38.3 meters. If you draw the diagram, then only you can answer this question. Otherwise, you cannot answer this. Unless the diagram is in your mind. Okay, by the way, this previous problem you solved it from A frame, no? Correct? You got the same answer.
Yes, sir.
If you stand on A, A is at rest. Correct? If you stand on A is at rest. Okay. Then B has to move. Then what velocity B will move? Tell me. With what velocity B will move? Velocity of B with respect to A. What is the velocity? Tell me. Velocity of B minus velocity of A. What is the velocity of B? 5 I cap. Correct? 5 I cap minus 10 I cap. Okay, correct? Sorry, 15. Yeah. So that means minus 10 I cap. So that means now with respect to A, B is moving which side? You have to understand. With respect to A, B is moving which side?
Left side.
Sir.
Yeah, left side. And the distance covered of B with respect to A is how much? You have to write how much? Plus 300 or minus 300?
Minus 300.
Yeah, that is what very important. For that I told you. Okay. So now once you write, you'll get the equation. Okay. So anyway, so that's all for today. So by that, what you call one dimension, we have covered almost. Okay. One dimension.
Sir, the answer is 38.333 meters, sir. Second one.
Yeah, 38.3.
Okay, sir.
I gave you.
Got it.
Okay. So once you draw the diagram, then only you'll get this answer. Otherwise, it's difficult to get. So you'll get to 33.3. You'll get not 38.3. Okay. So anyway, by that we have finished what we called constant velocity in which one dimension. Okay. Trains or cars crossing each other in one dimension. Constant velocity models. Okay. Next class we'll see very interesting model that's called Riverman problems, which is in one dimension and in two dimension. That means on Monday we'll see one dimension is just only upstream and downstream. Two dimension is crossing the river. Okay, this is very, very interesting. But for understanding this, you have to have some basic what we call terminology. Okay, that first if you understand the basic terminology, then you can solve any problem in this model. So we'll meet on Monday with this model. So until then, thank you very much. Have a nice day.
Good morning.
Thank